All right, here we go. Same thing we do every proof. Let's look at the givens and see if I can put an S or an A next to it. AX congruent to AY, is that a full side in both the triangles I'm trying to prove congruent? Yes or no? Okay, here I know we're having issues with this. All right, and it drives me nuts because nobody asks questions about it. What do I mean by can I put an S or an A? Ready? AX, is that a full side in triangle BYA or CXA?
Yes.
Yeah? No? AX, is that a full side in one of the triangles you've just highlighted?
Yes.
Okay. Is AY a full side in one of the triangles you just highlighted?
Yes.
So that means I get to put an S next to it if it's a full side. If it's more than a side, if it's a partial side, you cannot. And then there's nothing else for me to check because I have perpendicular lines. But I marked the diagram for you, but it still didn't get into my proof. So I need to put, and this is another thing that's starting to creep in that I'm getting nervous about. You can't say angle X is a right angle. I'm going to respond with, what's angle X? Because there's multiple angles up here with X as the vertex. Use 3 letters. Use 3 letters. You can't go wrong. AXC or AXD, same angle. And angle BYA are right angles. Perpendicular lines form right angles. And then usually right away, right? What's the next step after we write this? You tell me they're congruent. Now look, if this happens to be an HL proof at the end, who cares? It's still a correct step, and I'm not going to mark it wrong, even though I don't need to say they're congruent. If it is, I'm not saying it's an HL proof, but if it is, it's just an extra correct step. And I can count that as a pair of angles. So you have a pair of sides, you have a pair of angles. I need something else. And this comes from you. Okay? This will come from somebody here in a second. So look at all the sides and all the angles. Is there anything else you can tell me are congruent? 18, anything that you see? Triangles are highlighted. And usually when all the givens are done, usually then we look for what? Vertical angles and a reflexive side or angles, or any of those up there? Anything that you've highlighted more than once. That's a full angle or a full side. No? Triangle BYA, triangle CXA. I think they have something in common. Not going to let you give up. There is something in common that both have, either a side or an angle up there that they both have in common.
Is it angle XAY?
Is that a full angle in both?
Yeah.
Then why can't I count it? Right?
Yeah.
It's everyone, yes, angle X. All right, XAY, however you want, angle A. Angle XAY, congruent to angle YAX. And some of you guys that play the single letter game, yes, you could get away here with calling that just angle A. Again, why? There's only one angle that has a vertex of A, and it's right there. Reflexive. So I can count that as an angle. All right. Now here's maybe the tough question of the day. Angle side angle or angle angle side, right? And last week we discussed a little trick, or nothing's a trick, a method. If you're confused to see if the side's in between or not, what can I do to one of the triangles? Take it out and redraw it. So if I take BAY, for instance, BAY, I have a right angle at Y. What other markings do I have on or should I have on this diagram? AY. And what did we just talk about? Angle A. Pretty easy now to see if it's angle side angle or angle angle side. I hope. So triangle BYA congruent to triangle CXA, and then I say it's easy, but what's the method? 5? Anything there? All right, let's do this next one. All right, here we go. First thing we're going to ask, let's look at the givens like usual. FH and GE, look at those sides or segments. FH and GE, are they sides in the two triangles we're proving congruent? Are FH and GE two sides in the triangles we're proving congruent? Yes, they are. That means I get an S. Let's look at the angles I've given you. Are HFG and EGF two angles inside the two triangles I'm proving congruent? No, so that does not get an A. So now you know going into this proof, you need two pairs of corresponding parts that are congruent somehow. I think the first pair, I don't know. Do we see the first pair right away? Do we see the first pair right away? 27, do we see anything right away? EH, reflexive. Yes, it's shared by both. It's highlighted. All right, here we go. I'm going to let you loose here for about 3 minutes to see if you could come up with the other pair. I'm going to tell you, it is going to be, you're going to be on top, you got to be on top of your game to get this. It's difficult to find the third pair. But I want you to be strategic. Let's be strategic together right now. You're at a point where you're just plain stuck and you have no idea what that third pair is. What do I already have? Two sides. That means it can only be two methods, which would be what? Sides, right? It could be side, 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 which would mean I need what congruent? Okay, FE equal to GH. Or it could be what other method? Where is that angle in between the two sides I already have? Name it. Remember, I have FH and the reflexive side. I have GE and the reflexive side. Where's the angle in between that would need to be congruent? No, that would not be in between. It's got to be between FH and the reflexive side. It's got to be between GE and the reflexive side. So MEH, right? Congruent to MHE. Look, it's got to be one of those two. It can't be anything else. It's got to be one of those two because it's either side, 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 or side, angle, side. I'm giving you 3-4 minutes, whatever it takes. And remember, we have not used one given yet. Haven't even touched it. Probably gave it to you for a reason. All right, go ahead. This one's a tough one, guys. This one's a tough one. All right, here we go. Let's talk. So we had two options. Which one's possible? The answer is both, actually. Okay? This is probably the most popular and direct way, though, and that's the way I'll do it first, and then we'll do it the second way. How do I get FE and GH? All right? So how do I get those two angles congruent? Well, we talked about, before I let you guys go in your group, we never touched these two givens, this given here, that the angles were congruent. I got an isosceles triangle, don't I? And what do I know is across from those congruent angles? Congruent sides. Not now, are they sides in the triangles I'm proving congruent? No, but we're getting there. So FM is congruent to MG in a triangle. Congruent angles are across from congruent sides. All right. Now, how's that help? Well, let me go back to the given. FH and GE were congruent, right? These whole sides were equal. And now that FM and MG are equal, I can do subtraction to say ME and MH. Well, who cares, right? Who cares? They're not even sides in the triangle. Give me a minute. So I'm going to go FH minus FM equals GE minus GM. Subtraction. To say substitution, ME, segment ME and segment MH are equal. All right, well, why? Who cares? I can't use that as sides. Here's why. Those segments being equal leads to that. Because now that these are equal, what type of triangle do I have on the bottom? Isosceles, and what's across from those congruent sides? The ones we needed. Okay? So that's how you got the angles congruent. Angle MEH congruent to angle MHE in a triangle. Congruent angles are across from congruent sides. And now we have the angle we needed to say side angle side. Are we okay on that, how to get it that way? All right. I also want to talk, how do I get FE and GH congruent to do side, side, side? Because I want to give you a little taste, a little sniff to where we're going on Monday with the toughest proofs we've done to date. How can I get those two sides congruent? All right, forget my step 6 here. All right, forget my step 6. So I just proved ME congruent to MN by subtraction, MH by subtraction substitution. Everyone good? What type of angles are these here? Vertical angles, right? So now don't pay attention to these two triangles. Pay attention to the triangle on the left and the right, FEM and GMH. Why are those triangles? Or what do we know about those triangles? They're congruent by what method? Side angle side. Everyone agrees? So if they're congruent by side angle side, why would FE and GH now be congruent? CPCTC. Okay, so I could have gotten them that way. That's where we're going on Monday. Proving a pair of triangles congruent to get another pair congruent. Okay, that's where we're going on Monday. Questions there? Okay, here's where you're going now. I'm not just going to let you go right to the assignment because we need all the practice we can handle, and I need to see how you're doing individually. So you are going to back to the homework that you didn't have last night. And again, I'm holding up my end of the bargain. Anybody have to do it at home? Nope. Okay, just making sure. We should be on this one. Okay, some of you started or finished it, then you go to the next one. If you started and finished it and I gave it the okay, then you go on to tonight's assignment. So I want you to finish the proofs from yesterday. I need to check every one before you go on to the next one. And then once you have the ones from yesterday done, you can go to tonight's assignment. All right, so let's get going. Let me know if you just want, I'm done with the groups. If you want to work it with your groups, that's fine. But once you are done with the proof, call me over. Because I know some of you work faster than others. So call me over, please.